This next section is weighting, parking, and condition variables, and it starts out. It's where the book starts to really show what the book is about. It gets really complex, but it's kind of showing. In this video, it's going to demonstrate why a convar exists, and it starts out by starting with parking. It kind of shows like how you can manually get a thread to go to sleep, and then wake it up when there's something for it to do. So let's just start reading. But if it looks really complex, it's because it's leading up to a better solution. So let's read it. When data is mutated by multiple threads, there are many situations where they would need to wait for some event, for some condition to become true. For example, if you have a mutex and it's protecting a vec, you might want to wait until it contains anything. And that's because, while a mutex does allow threads to wait until it becomes unlocked, it does not provide functionality for waiting for any other conditions. And if that's all we had, we would have to keep on locking the mutex to repeatedly check if there's anything in the vec yet, and that's not ideal. So what you have is thread parking. And by the way, there's a crate called parking lot, and that's where you can see that word parking in there as well. It was kind of like one of the later on it got merged into the standard library, so I don't think it gets used as much anymore, but it's kind of interesting how you see that term there as well. So thread parking. One way to wait for notification from another thread is called thread parking. A thread can park itself, which puts it to sleep. So it does that itself. It stops it from consuming any CPU cycles, which is good. You don't want to do that. And then another thread can then unpark the parked thread, say, hey, we've got something for you, waking it up from its nap. Thread parking is available through the standard thread park function. For unparking, you have a similar looking function called unpark on a thread object representing the thread that you want to unpark. Such an object can be obtained from the join handle returned from spawn or by the thread itself, standard thread current, and that gets you the access to the current thread. So let's dive into an example, and so what it does is it uses a mutex. It makes a vecdeck to share a queue between two threads, and what will happen is one thread will consume items from the queue, while the main thread will insert a new item into the queue every second. And thread parking is used to make the consuming thread wait when the queue is empty. So let's, whoops, not that, there we go. So let's type this out. Where are we? So first thing we do is queue equals, what do we have? A vecdeck, a mutex vecdeck, mutex new vecdeck new, and inside there we have nothing. It is an empty queue. And then the next thing we do is we use a thread scope, a scoped thread, and then we're going to, by the way, type annotations needed, but it'll figure out the type soon, so don't worry about that. So here we have the consuming thread, and let t equals s.spawn, and we have to give you get the scope join handle, and you can use that to spawn threads inside this scope here. And what we're going to do is, let's see, there's going to be a loop, and then inside there, so let item, try to get an item from the vecdeck. So you go q.lock unwrap pop front. So see if there's anything at the front, and then see what happens. So there might be an item there. So if let some item equals item. Interesting example of using the same name here. Rust also has shadowing, where you use the same name throughout because you don't really care to give everything the same name, because you only care about like the expression at the end. So let's see, did I do this right? So yeah, you pop the front, and then if there's an item there, then you debug. You just print it, and you could also just do a print line here. Else thread parks. So the thread says, okay, I don't see anything here. I'm going to go to sleep. Producing thread. So here's the producing thread. So this is like the main thread here, and here is like a separate thread. So for I in 0 dot dot, and that will give you an I that goes up forever. And what it's going to do is q dot lock dot unwrap, and then push back I, and now this this type annotation problem goes away. It now knows what type it is, so we didn't even have to say what sort of a vecdec it is. So you can say vecdec I32. It knows what's going on, and then so you give it an item, and then say t.thread dot unpark. So that is so you can see thread is the that's the handle to the underlying thread. So that's why you have this T here. It gives you a handle, and then you can say, okay, you get access to the thread, then you unpark it and say, hey, it's time for you to wake up, and then it's going to go to sleep itself for a duration from seconds, 1 second, like that. And I think I typed it exactly as in the book. So let's run it. And you can see, there you go. So it's picking up the item every time. This thread is putting itself to sleep. This guy puts an item on there, and then it hangs around for a second, and then there's no using CPU cycles in between.